Hello everyone, my name is Mushahid Muhammad Khan and today I am going to give you a presentation related to my subject Engineering Research Method ENGG 851, and topic for today is Magnetic Coupler Design in Wireless Power Transfer for Electrical Vehicles. This is my content. First I am going to give an introduction on wireless power transfer technology. Then we will talk about its basic operation. Then we'll talk about operation of its segments, its core structure, then research design. Then we will talk about conclusion, and at the end we will talk about references that I have taken. Introduction. Wireless power transfer technology uses electromagnetic induction to transfer power from one body to another. The field of wireless power transfer technology is tremendously growing, and lots of research is going on this particular topic right now. Wireless power transfer technology can be used for stationary as well as in motion charging of electrical vehicles. Now, what do you mean by this? For stationary charging, it means that the vehicle is parked on the charger. It doesn't have to move anywhere. And in motion charging means that the vehicle is moving on the charger. Now, wireless power transfer technology uses loose magnetic couplers to transfer power from one body to another. And it has a very high efficiency, and they are very reliable. Now we will talk about basic operation of wireless power transfer technology. Wireless power transfer technology should consist of a high capability. It should have a very huge air gap. It should be resilience, and it should have a good resilience, and it should weigh less. Now, what happens in this that AC power is first converted into DC power, and then this DC power is converted into high resonant current source. Then this resonant current source in the coil develops a magnetic field. Uh, Develops a magnetic field, because of which a voltage is induced uh, in the secondary coil. This process is very much similar to a transformer. Then this voltage goes to a compensation network where the power efficiency is improved. What now you will ask, what is compensation network? Compensation network is nothing but a power converter. Now, coupling relies on the gap between the two coils. Now, if there is any misalignment between the two coils, then there is a decrease in mutual inductance, and because of this there is a decrease in power efficiency too. Now, how to improve this? To improve this, we have to use good quality coil design. Now we will talk about operation of its segment. This is basically for vehicle in motion. Now what happens in this is that there are some segments, or we can say charging points, present on the street or on the road. When the vehicle arrives on the first segment, there are some sensors present on each segment. These sensors give signal to the inverter to turn on the segment, and when the vehicle moves forward, then the sensors give signal to the inverter to turn on the next segment and turn off the previous segment. uh, this whole process is controlled by the sensors. Now we will talk about structure of core, and it's very important for us. In wireless power transfer technology, there are two types of core structures. One is EE type and another one is UU type. In uh, UU type consists of 50% nickel and 50% iron alloy powder. In UU type, two U types are combined together, strangled with electrical cables. Strangled with electrical cables. Now, a question arises that why do we use two U types? Why don't we use single type? To get high efficiency, we have to use two U types. If we will use single U type, then the efficiency will be very less. And same implies for EE type. In EE type also we use two E types, strangle them with electrical cables. Now we will talk about research design. There are two couplers. There are two couplers present. One is primary, or we can say transmitting coupler. Another one is secondary, or we can say receiving coupler. Now, it is necessary that the value of coupling coefficient and quality factor should be high to have a very high efficiency. Now we will talk about coupler in stationary charging. There are two types of couplers. One is single type and another one is double type couplers. Now double type couplers are not that much used because double type couplers have uh, very high leakage flux. Because of that, they are avoided. So we use single type couplers. In single type couplers also there are two types, circular pad and DD pad. And DD pad has a very high efficiency and they have a very good tolerance as compared to circular pads. Now we will talk about couplers when vehicle is in motion. In this also there are two types of couplers. One is W type and another one is I type. In this also we combine two couplers together. Like we can combine W with I or I with E to get a good efficiency. Now we will talk about conclusions that we have made till now. It was observed that the efficiency and electromagnetic induction can be improved in stationary charging by using power converters. But to deploy power converters, it is very expensive. So instead of that, we can use intermediary couplers, uh, which provides very high current source, a very high resonant current source. And these current source can be controlled by using power switches. Uh, Now, for vehicle in motion, still more research has to be done on this particular topic, and it has a very huge scope in the future. And these are my references, and thank you.